Hi, so I am Francois LeFloch. I'm a HealthShare Solutions Engineer working for Alex McLeod. She's going to present the panel on Wednesday if you don't know her, and I recommend you go. Today I'm going to present implementing single sign-on for UI integration. Just to go quickly over what I'm going to talk about. First, as a way of introduction, I will talk about what the problem is that we're trying to solve, where single sign-on comes in as a useful solution for you. And for today's presentation, I will focus on a particular example of browser single sign-on using SAML, the SAML standard. So I will explain a little bit what the SAML standard is, and after that, talk about single sign-on strategies you can implement using HealthShare, which are simple URL link and shared identity provider used for domain authentication and authorization. I will summarize a little bit all of this into how you can use tools in HealthShare information exchange to implement single sign-on. And finally, I'll present in demo a couple of examples of how this is implemented. This is going to be a fairly technical presentation, so I'm going to go into a lot of details, technical details. If you have questions, feel free to interrupt me or take notes for the end, either way. First, single sign-on. Why do I need single sign-on? This is the typical situation that we're trying to address, where a user, such as a clinician, is confronted with multiple software solutions. And here, I put this as an example where my user is in front of the computer and has to deal over the course of the work with appointment scheduling, billing, connected devices, electronic prescription, an information exchange, an EMR solution, maybe some project collaboration application, human resources, and maybe even ride-sharing. And if you think ride-sharing is a kind of a bogus example, it actually is not. We have had some customers in Belgium that asked to integrate that with the rest of the information exchange, so a ride-sharing application for the hospital employees. So when you have all these applications, and you have to deal with all of these, this is what you don't want to have happening. All these logging screens all across, and whenever I go from A to B, or I need to change my application I'm working with, I have to type a new login. This is annoying. This is a waste of my time. I don't want to have to do that. And this is where we see the opportunity to use single sign-on. So single sign-on features would allow you to log in only once for all of these applications. This means sharing user authentication information, so avoiding these repeated logins, and experience some sort of continuity between the applications. One of the implications that will come with this is obviously either centralization or a way to match the user profiles that you have defined in each application. Also, with a single sign-on solution, you will be able to share potentially application context. And what I'm referring to here is, for example, going from an EMR to a health information exchange, you could pass the context of who the patient is that I was looking at. This way, jump directly to the record in the information exchange or in the EMR and vice versa. The traditional approach for sharing user information between application favors single UI development, and this is kind of the way saying that most of the time you'll have the vendor saying, well, my solution will do everything. Why don't you have everybody else produce some kind of API and I will integrate with them, or maybe we'll integrate in the background using server-side methods, and typically server-side mechanisms like LDAP, SSL, and TLS, Kerberos tokens, or other sorts of web services. And this is all supposed to happen in the backend, but the UI would be just made by one vendor. This is great, and this has worked well. However, nowadays, these things are kind of changing, and this goes back to what has been discussed in the keynote. All of this world is kind of changing. The development landscape changes very quickly. There's a mix of a lot of applications with different languages, different use cases, and so the mix of legacy and new application sort of disrupts this historical approaches. You want to have the software as a service solutions in the cloud, and because of this, for example, you would not be able necessarily to have everybody work with servers in the same domain. The new applications that are developed, offered in the cloud, they don't want to spend time setting up a VPN and figuring out how to integrate the users on the server side. At the same time, the end users really want to deal with the startup companies or specific companies that excel in key areas. And this traditional approach, which is kind of heavy, is an obstacle to have this best-of-breed solutions being integrated together. Last, I want to mention that browser single sign-on is already quite widespread, and it's not uncommon that you would just go to a website and you already have these things that are single sign-on solutions plugged into any sort of website, signing with Yahoo, Google, Facebook, etc. Of course, I'm not going to talk today about using Facebook to log into your HealthShare account, but this is going to be a very similar approach, actually. How do you define and implement a single sign-on strategy? First, you will gonna have to consider exactly what applications you're dealing with, because a lot of these applications are gonna deal with and manage users a lot of different ways. You're gonna have first to question whether they can share this user information. If they're completely locked down in the silo and they're not allowing anyone to exchange information or delegate authentication in any way, this is just not gonna happen. Second, you're gonna have to look at how many applications are involved, and I'll get back to this, but it's actually quite different when you have to integrate only 2 applications and actually a whole range of applications under one ecosystem. Last thing to consider, how much effort this is gonna take you as an implementer, as a developer, because maybe these applications already exist and you're gonna have to migrate some logins that exist on one end to another. You're gonna have to think about embedding applications or just putting links between one another. So this is kind of an investigative discovery work that you're gonna have to do before even thinking about how you solve the problem. So once you've decided for single sign-on, and in particular for web browser single sign-on solutions, one thing I've observed is that most of the time it will revolve around sharing security tokens. And I'll explain. Security tokens can be random sequences, or they can be cryptographic objects representing the users and some information about them. The main security protocols nowadays are essentially SAML and OpenID OAuth. There is a couple of others, but those are really the 2 leaders that you're going to see in the field. And they leverage essentially either XML or JSON as a transport mechanism. So this being said, going back to the idea that you have to look at your applications, you have to see if your applications can all be compatible with either of these or both, and how they will allow single sign-on to be implemented. The good news is that HealthShare allows all of those to be implemented, and they're actually quite already, there's quite a lot of work already done for you. SAML is already built in some part of information exchange for the purpose of the IHE profile XUA. So you have some standard templates and code that you can rely on. And OAuth, on the other hand, is already used and implemented for the Smart on Fire apps. So for today's presentation, I will just talk about web browser single sign-on. I will not discuss the back-end integrations, web services, or other things that I mentioned as the traditional ways. And I will focus on the SAML standard, but the same would apply, of course, to OpenID, OAuth, and other JSON-based transactions. I've put here on the right a table sort of putting together the differences between OAuth, OpenID, and SAML for reference. I didn't make this one, by the way. It's something I found online, so it's not anything that InterSystems made up. Just quickly, I won't go through all the lines, but a couple of things. OpenID and OAuth 2, unlike SAML, are not completely authentication and authorization, where SAML can cover both. SAML is a fairly old standard compared to the other two, and has already had 2 versions. Last thing I wanted to mention, it's talking about how here at the bottom, SAML may not be well suited for mobile. Actually, I find this quite arguable because in the case of HealthShare, a lot of the SAML processing is done on the server side, so it's not so much a problem of the mobile application that it is about the server end capability. No questions so far? Okay. So I'm going to dig in a little bit into the SAML standard. If you already know what SAML is, this may be information you already know. Otherwise, I hope this will be a good introduction. So SAML stands for Security Assertion Markup Language. It's an OASIS standard created in 2001, and that was updated in 2005. It's XML-based, focused on exchanging authentication and authorization data, and it recommends the use of particular cryptographic standards, like the use of SSL TLS certificates and XML signature, which is an XML standard for signing content. The specification of SAML defines actors using and exchanging SAML objects as identity provider and a service provider. Simply said, the identity provider is the one that detains the information about who the users are, what their properties are, who is allowed to do what, and the service provider is the one that is requesting those to use those SAML objects. The objects the objects are separated in sort of 4 different categories that are packaging each other, if you want. At the center, at the bottom, there's a SAML assertion, which is really what I call the security token. It is what contains the information about the user, the authentication, the authorization statements about this user. And all the other objects that encapsulate it correspond to how you're going to handle it. So you have first protocol messages that are going to say, this is how you package a SAML assertion into a request or a response or a query. And you have the special case of artifacts where you're going to have random sequences that can be equivalent, be made equivalent to a SAML assertion. Bindings are going to be how you transport these messages, and you're going to have in the specification definitions about how you should handle HTTP transport or SOAP web services to exchange these different messages. And finally, profiles that are sort of the overarching logic that says how you're going to work together between all of these messages, all of these bindings, in the use case of, for example, web browser single sign-on. So simply said, who is going to request it, what is going to be in the response, and if I use option A or B, exactly how these messages are going to be involved in what sequence between the different actors. Okay, so a lot of the use cases where we look at SAML are use cases that are not defined by the OASIS organization, and actually they often leave unspecified how the SAML assertions are issued. So everything I just mentioned last, the protocol, the bindings, the profiles, most of the time is something that is not clarified in how this SAML assertion came into play in a given process. And so if you take for example, the IHE profile XUA is just saying in some message you're going to put in a SOAP header, you're going to put a SAML assertion. It's not going to say how you got it, who were the entities, what kind of transport interfaces you use to get this SAML assertion in the first place. It's just going to say, put it there, and somebody else on the other side is going to have to verify it. This is an example, and this is probably a little small for everyone. Is it probably too small for everyone in the back? So it's good because I zoomed in on the next slides. This is an example, but this is sort of the bulk picture of an XML containing a SAML assertion. And so I'm going to go through the details of different pieces. First thing is that if you were able to read a little bit of this, the first thing you may have noticed is that it's actually plain text. It's completely readable. It's actually not encrypted. So one of the first rules you need to remember is that SAML does not ensure confidentiality. It's not something secret, as it is. So whenever you use SAML, you still need to have an encryption transport mechanism to ensure confidentiality between the two parties exchanging it. On top of that, what you will find in the SAML assertion is some other objects that maybe you saw as these long strings here. And those are the hash and the signature. And one of them, the hash, is here to ensure integrity. This means that if you modify, if some intermediate decided to modify part of the SAML assertion, the hash would not match something you could calculate from the SAML assertion, so it would fail validation. And the signature ensures authenticity because it contains a certificate saying who issued that. I'm going to go through the contents a little bit. I hope this is better. So I'm just going to go very quickly over the contents, just to say that there are a couple of items that are required, like identifier, some time stamp of when it was issued, version, and more importantly, who issued that SAML assertion, which is typically the identity provider I mentioned earlier. And you also have the signature, which is a big block like here, explaining how this message was transformed and what cryptographic algorithm it used to produce different parts of it. So you can see, for example, that you have here a SHA-256 algorithm to calculate the digest here. Further down, you're going to see some standard pieces of the SAML assertion, such as the subject. And the subject in the specification says that it should identify the principal. Now, I will come back to this, but this is kind of an ambiguous term for most use cases. So this is something that is usually kind of unsatisfactory for end users. But I'll come back to this. Other pieces of the SAML assertion, the conditions that are going to state when this assertion can be used. Typically, it's going to have a time interval that says you can only use for these 10 seconds this SAML assertion. After 10 seconds, this should be considered invalid. So other statements about the authentication and authorization mechanisms that were used to collect it. Last, there is this thing called attribute statement that would contain miscellaneous properties. And I'm going to go into details a little bit here just to explain. So this part of the SAML assertion definition is open-ended, and it's subject to different implementation policies. It can contain string values, coded values, and your organization may decide that some are required, some other are optional, some are allowed, others are not allowed. And all of this means that whenever you decide to implement anything that uses SAML, you actually need to define what is going to be in it. It's just not enough to say, oh, we're going to exchange SAML and that's it. You're actually going to have to say what validation criteria are going to be used. Do we need to actually put a time limit? Do we actually need to put restrictions on information such as the issuer, so typically the issuer would be the same entity that is in the certificate subject that is contained in the assertion. And also I mentioned the subject. What are you going to put this here to identify the code principal? Is this a user ID? Is this a login identifier? And if you know information exchange, user ID and login ID can be two different things. Can it be a full name? And I put here, there is a Swiss standard where it says that it has to be a full name, a full readable name. Sometimes it's going to be just a tokenized identifier, like a GUID, and so on. So there's a lot of different ways to see this implemented. One thing that is worth mentioning here is that in IHE XUA and in IHE in general, there is a standard that is defined that is called cross-enterprise security and privacy authorization. And that says that a lot of information that is useful for medical use cases, for IHE use cases, should be put in the attribute statements, so the open-ended sort of black box, with different properties corresponding to different things. So in most IHE contexts, you're going to see that subject ID is going to have some identifier of the user/clinician. The organization and organization ID are going to say who is associated with this user subject ID. So it's kind of similar to MRN assigning authority. So it's a doctor number and the assigning authority that corresponds to it. You're going to have roles that are defined. So is the user a clinician, a nurse, an administrative person? That's what you're going to find in the roles. The purpose of use, typically we see there the different cases where the same user is accessing data, for example, emergency versus normal access. And the resource ID, finally, is usually where you put the patient. So this is the patient that is being accessed for this specific security context. All right, so I've talked about all of this, and you're probably already wondering, okay, but how about HealthShare in all of this? Well, SAML is supported in HealthShare, like I said, and one thing I mentioned here is that HealthShare information exchange can be used both as an identity provider or as a service provider. It can sit on both ends, either creating, managing the user profiles and creating security assertions, or being on the service provider end, taking in those SAML assertions, processing them, extracting information, validating that information, and using it to authenticate users. And so you will find in InterSystems Iris or Cache and Ensemble, if you haven't migrated yet, a complete set of SAML classes and utilities to handle those SAML assertion objects. You're going to find object and XML projections. You're going to find standard methods for creating, signing, validating, extracting all sorts of attributes from SAML assertions. On top of this, HealthShare will have the healthcare-specific implementation that was developed for XUA purposes, which means that you have two classes, creator and processor, that will add some essential features like a schema validation, a method you can override to provide the list of expected attributes and specify that such attributes would be string versus coded entries. And also methods to check the certificates and compare your X509 certificate that comes into a SAML assertion with system configurations. And you will have, so you need to extend these classes for your own specifications, and you have two examples provided in the HealthShare, in actual HealthShare packages for two use cases, eHealth and Shini, that were used with customers previously. All right. So choosing a single sign-on strategy, I've decided to put all the things I've seen in the field into two buckets. Two options that I've seen are the main ways people have implemented single sign-on. The first option is to have just a simple URL link between application A and application B. So what you're going to have in this use case is on the left side, some application. The user is going to this application, logging in after getting a prompt, getting to some application page. Going to do something, for example, on your EMR as logged in as user Sam Farrow. And after some time, maybe you want to navigate to your other application B. And what's going to happen is that you're going to have a link somewhere in your first application that's going to produce this SAML token that's going to give the user, the end user in the browser, a redirection instruction containing this SAML assertion, and you're going to use this to go to the other application and automatically log in. So I sort of call this a bilateral trust because it's really one-on-one. What happens is really that the service provider on the side of application B essentially needs to have the certificate from application A and will trust the SAML assertion coming from it. And it can work symmetrically. You could have the other way around, somebody navigating in your application A, for example, HealthShare's clinical viewer, and deciding to go to the MR. And it could use the same method, create a SAML assertion, signing with my certificate of server B, and then A will just have to trust that application and log in automatically the user. So in technical terms, this is called a non-solicited SAML assertion and is part of the SAML 1.1 standard. Once you've done all of this, one thing important to notice is that you still need the user profiles to be matched, right? In this situation, both sides have their own set of identity user management. They have the set of user permissions, roles, everything, and you need to have a way to match those when you switch from one application to another. Now, I just want to point to one thing about this solution. What happens when you have more than two entities? This is what's going to happen. A logs into B with a single sign-on link, so B needs to trust A. Now, if you go from C to B, I come into application B with a SAML assertion signed by C, so I need to know who is C. I need to trust C. I need to know, I need to have the certificate from server C. C to D, same thing, and so on. So you can see all of these imply that every service provider will need to collect all the server certificates from all the ones playing the identity providers to support the links that are coming from them. And if you start with this picture and say, all right, tomorrow I need to add one more application, now, in principle, if I wanted all of them to work together, I would need all these 4 applications here to collect one more certificate, and this new one to collect everyone's certificate. It's kind of getting complicated to manage. So in that case, I would actually look at another option, and this is option 2, where we talk about a federated identity provider using some domain authentication. So the same idea as before. The user here is trying to go to my application A, say my EMR, but this time, this application is not going to let you log in like that. It's going to say, wait a minute, you're not logged in. You have to redirect to the identity provider, the centralized identity provider. I'm going to give you a redirection URL so that after you logged in, you come back to me. But you need to first go there and answer to this login prompt. Once you're logged in into the identity provider side, only the identity provider will give you the SAML assertion so that on the server A side, I can trust who the user is. So what's different in this picture? Obviously, only one identity provider. It's not exchangeable. It's not symmetric. So when you extend this, the same picture as before, to a lot of different applications, now, let's say B is the identity provider. Every one of these single applications, when you need to log in, will redirect you to B, and B will process the login. And once you come back, you just have to trust B. So it's much easier because now it's only one certificate that you have to share between all your applications. Again, let's say tomorrow there's a 5th application coming in. Good news, you don't need to change anything to the ones that are already there. They don't need to know anything about this new application. Only thing you need to do is that the new application needs to know about the identity provider and integrate with it. So, a couple of side notes. You still need to do the user profile matching. This is not something that is different because all your applications supposedly will have still some kind of profiling that you need to apply to your users. The change is that now you only have one central entity to match with. You don't have to think about, okay, in this one I had 5 profiles, this one I had 25 profiles, which one matches which in my 3-profile application down there. Of course, on the other hand, this is actually more complicated to implement because the first thing I told you is that the login process, you have to eliminate your application login. You have to figure out how to redirect to somewhere else, and when this comes back to process the authentication tokens that came back. So this is a relatively more complex sequence of events to manage. And I mentioned a lot of variants exist. I've described here a fairly simple one, but you can actually have more complex schemes where you don't get just a token, you get a sort of artifact, and then you have to, in the back, still communicate between the entities to know who the user was. There's a fairly large number of elaborate ways to enhance more and more and more the security between all these entities. Okay, so this is just to summarize the 2 options I've discussed. So option 1, simple URL link. It's a relatively small development footprint. You just have to produce that URL, put your link somewhere in your application. And then it's fairly flexible in the sense that all the sites can sort of retain their identity management and just need to focus on accepting these external ways to authenticate with a SAML assertion and match the application profiles. I would say it's a relatively good fit for legacy or applications where you don't want to do a lot of work. And from what I showed before, it's also really best for when you have just one-on-one application and you just want to do something simple that connects the two. On the other hand, the other option is going to be a better fit for a large number of applications that want to have really one centralized authentication place and share a sort of ecosystem of federated authentication. But you will still need to match application profiles. Last time I mentioned this is a good fit for, like I mentioned, sort of modern add-on style application. It's actually what is done in Smart on Fire, not with SAML, but with OAuth. Yeah, this is just a good fit for those. All right, so before I start and do a quick demo, just to give you some guidelines about how you would go about information exchange and implement this in practice. So I mentioned this earlier, but again, the first thing you need to do is make a lot of implementation decisions. What standard you use, what extensions, specifications you're gonna have to put in place and agree on between all the parties, all the applications that are being used. What strategy you use for single sign-on, in particular between those two I mentioned, and how you're gonna do profile matching. And I'm just gonna stop here 1 minute to say, user profile matching, you also have a lot of different options. You can decide to dynamically provision the user, saying, application A told me this is user Sam Farrell. I'm just gonna create a new user if I don't have it already, and pick up the profile that it gave me. Sometimes you're gonna have opportunities to do deterministic matching. So in the SAML assertion, you could put an identifier for this doctor, and maybe you have it in your database, so you can just match it, even though it doesn't have the same login information or properties. And of course, provider directory is sort of a golden standard if you can use the shared database to match your providers. Second thing is matching of application roles between the two parties versus using standardized roles. And in the roles specified in the IHE standard, you may often see, for example, SNOMED codes that are used to identify the clinician roles. And this way you could decide to have a standard shared between all the participating applications. But this is, again, part of your definition. And so having this specification really is important, and I kind of hammer this again, but this is the key really to the success of your application. Don't just rely on saying, hey, let's just use SAML, that's it. We're gonna figure this out. All right. This was just here actually to give an example of standardized profiles for the roles, and this is the actual SNOMED table of roles. So you see like physicians, pharmacists, patient, etc. This is, you can find references like this online on if you don't have any particular idea of where to start. So using information exchange, you have your two options. If you want information exchange as an identity provider, what you may want to do is use the user clinician registry as an identity management and authentication authorization solution. Then you can leverage the SAML creator class to address the SAML specifications you just decided. And this URL link can be built using the SAML creator class to pass the SAML assertion as an argument, for example, of the link, the HTTP link between your two applications. And there's even two options. You can use HTTP GET or POST, depending on the context. Last thing, in general, you will also use a custom login page to redirect the successful logins to a service provider. So the service provider comes into information exchange, you log in, and this custom login page will know what to do after login. That is, go back to the service provider with the credentials. Now, if you're using information exchange as a service provider, it's the other way around. You're authenticating via the SAML assertions. So what you will need to do is look at HealthShare authentication processes, and you will have to customize the security domains in information exchange, which goes through the HS authentication callback class definition. I'll show this briefly in the demo. The SAML processor class can be used as a model to address the validation requirements. The custom login page, again, will be used, but this time on the server side, service provider side, to process the returning SAML assertions and authenticate the user, or in the first place, when you're not authenticated EDS, to push you towards the IDP. All right, and that's time for the demo. So actually, I have two parts in the demo where I show essentially the two options I discussed. So the first one is the simple URL link, where I'm going to show you two servers that I called IHS, IHE 1 and 2, and how to navigate between one and the other. So this is the URL. We're on the number 1 server, and we're prompted for a login. So I'm just going to log in as sferal. And let me just zoom out in time. Oh. Wait. 2 hours. Yeah, that works better. Thanks, Sean. Got my back. So here, I've just created a sample user page. So this is just any application. You could imagine this being your EMR application. And we're on the number 1 server. And let's say that after we did something with our user here, sferal, we want to move actually to a different server, server number 2, that has a clinical viewer. There's an information exchange to switch applications. If you just had a link, a regular link like this one, that's really not visible. How do I change the zoom on this? It's better? Right. So if you just had a link like this, what would happen is you just end up with the login screen. Same story as before. Really annoying, and really we don't want to do that. Instead, I created this single sign-on link, and what you're going to see is that this link is going to use the same URL. However, it's going to have in the URL another argument that's actually going to pass a SAML assertion. So it's here. You have the SAML token that is passed in the URL itself, and you just end up on the second server, HSIE2, with a user that's not sferal, it's SAML feral. And that's it, really. So just to show quickly, I'm running a little out of time. That's all right. Too fast. If I took this SAML assertion and I copied it, let me just take this to a better window. Where am I? This is just a base 64 encoded version so that I could put in the URL, and I could just URL decode and then base 64 decode, and then just show it as an XML, just to prove to you this is what contains the entire SAML assertion. So the same thing I showed you before with all the cryptographic information, with the user passed here. Maybe you cannot see very well, but it actually has some identifier here, a doctor identifier, and I use that identifier to match the user as feral with SAML feral on the other app. Oops. Wait. All right, so this is great. Let me log out of the second server, go back to the first one, go back to this user sample page, and maybe you'll think, well, this is great to have a link, but it would be actually better if I could just embed this page. And I'm just going to do that here before everyone leaves. So here, same thing, but now I just have embedded the page of the second server inside the first server. So you can see this is the second server inside the first one. The user is feral here, SAML feral, seamlessly integrated the two applications on two different servers. All right, so let me log out. This is one way. Now I can show you the other way around because this is symmetric and I have to accelerate. It's all right, yeah, 15 minutes between the sessions. Just show quickly that you could also just put in the clinical viewer the link from the second one to the first one. So this is just doing the other way around, right? All right, and okay. So just to show the second example very, very quickly. So this one was using a link. In the second example, I'll just show the federated authentication. What's going to be different in this time is that I start with the server 1, and this time the login screen, so you see I'm logged out. The login screen is actually going to redirect me to the server number 3, where I'm going to have a login page. So here I clicked on the link, and you can see there is an immediate redirection with the URL. And you can see at the top, maybe, that it has the server 3 here with some redirection instructions saying, well, after you logged me in, please come back to that page here. So here I'm going to log in as sam.feral. Another third different way of having a user logged in. And what's going to happen is that I logged in as sam.feral, but I'm actually back to server 1 as sferal. And you can do this for multiple applications. You can see this way that one server, server number 3, is the identity provider, and all the other ones are just going to use it for authentication. If you I don't have enough time. I wanted to go a little bit through the code, but let me just explain quickly that the way I've done this using information exchange is a combination of changing the custom login page so that all these dynamic redirections happen, and also using things that are built in, such as the security domains here, where you can specify here a single sign-on domain for authenticating users, and plug this into information exchange to say, when I log in, I'm going to look at this custom single sign-on authentication class to ingest my SAML assertion and extract all the user information I want from it. All right, I'm sorry if this has been a little quick, but questions? I actually go back to the slides. There I go. Right, so this was the second example. Questions? Yes? No? It was a little complicated maybe, but I warned you, it's technical. Thanks. Thank you.